Good morning, Geo Metro Ninjas, and welcome back to another awesome day of virtual Mr. Coach. Today we're going to be talking about the distance formula on the coordinate plane, and to get this going, we're going to throw it back, a little flashback Wednesday, if you per se, or whatever day you're watching this. I think it's Thursday, Throwback Thursday. We are going to talk about our dog Pythagoras. So if you remember back to our early days of geometry when you were just little Geometro Padawans before you became full-fledged Geometro ninjas, we learned about this dude Pythagoras. And Pythagoras developed a theorem that helped us solve for missing sides of a right triangle. And you're like, Coach, what on earth does this have to do with distance formula? Just give me the formula, let me plug it in, let me play. Well, I want to explore a little bit and see if we can't determine where the distance formula was developed. Okay, so let's take a peek at Pythagoras. These guys say leg squared plus leg squared equals hypotenuse squared. Okay, that is 100% true, but we know it better as, say it with me, a squared plus b squared equals c squared. Absolutely. So we can write that in if we want to. Oh goodness, where are you going, computer screen? So we got a squared plus b squared equals c squared. And remember, our hypotenuse is the side that is always opposite the 90-degree angle. So we're only going to do two of these. I don't want to do a whole lot of overkill when it comes to Pythagorean theorem. You guys are rock stars. You can crush it. So let's take a peek at this first one. It says, use the Pythagorean theorem to find the length of the hypotenuse. Well, so we're on a coordinate plane. That's why I wanted to bring this to our attention. Since we are on a coordinate plane, we can count the lengths of each side based on the number of boxes or coordinate points that it covers. Okay? So we've got our horizontal length here, and it's 1, 2, 3 boxes. So that side is 3. I've got our vertical leg here, and that covers 1, 2, 3, 4 boxes. So our length is going to be 4. But when we take a peek at our diagonal over here, let me find a different color. What do you think? Gold? Gold sounds good. When I take a peek at my diagonal, it's not as simple as just counting boxes because it doesn't go horizontal or vertical where I could just count the boxes and I'm good to go. Like I can't just go 1, 2, 3 boxes because that's not the case. So this is going to be our hypotenuse. This is going to be our c squared because the vertical side and the horizontal side are perpendicular. And if I really wanted to, we could say that they are perpendicular because a vertical slope and a horizontal slope are opposite reciprocals. But I digress. So let's use our Pythagorean theorem. A squared plus b squared equals c squared. We're going to substitute the numbers we know. 3 squared plus 4 squared equals our unknown c squared. 3 squared is 9. 4 squared is 16. And again, our unknown hypotenuse. Nine plus 16 is 25. And then we need to do the square root to get c by himself. So we know the missing value of that third side is 5. So our dog Pythagoras helps us get there. We can go one more again. We got a horizontal length of 1, 2, 3, 4. A vertical length of 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, that's going to be a square root. And then our unknown hypotenuse. So again, we're going a squared plus b squared equals c squared. 4 squared plus 9 squared equals c squared. 4 squared is 16. 9 squared is 81. C squared is our unknown, of course. (16 plus 81 is 97. To get c by itself, we're going to square root both sides. And then the answer for our length is exactly the square root of 97. So you're like, Coach, what is the point of this in relation to distance formula? So I want you to put on your thinking caps with me. So if I look at this problem right here, 4 represents the number of boxes that the x changes. So let's say that is the change of x. Remember delta x. Hey, that's what 4 represents. It represents how far is it from -3 to +1. Well, that's 4 units. 9 represents the change in y units. Okay? How far is it from, what is that, 1, 2, 3, -4 up to +5? So we got the change of x and the change of y. And how is that related? So let's just pop it up here. So if we're just speaking right out of the box, we've got change of x, and then we know that number squared, and then change of y, and that number squared, and then over here we were able to get our hypotenuse. Well, one more modification. What if I just wanted to have c by itself? It would be c, right? And then how would we undo that c? Well, you are correct. We would then square root both sides. So if I square root both sides, and I haven't plugged in any numbers yet, every time I do the Pythagorean theorem, if I know I'm solving for a hypotenuse, I could always write this formula as the square root of our change of x, delta x, plus the change of y, delta y, squared. So the square root of the change of x squared plus the change of y squared is always equal to our hypotenuse. Now let's go take a peek at our distance formula. You're like, Coach, what are you doing? All right, all the rest of these notes will be filled in so you guys can find it. Well, there's my distance formula. Distance equals x2 minus x1 plus y2 minus y1. And look what we just figured out when we talked about the Pythagorean theorem. It was the change of x squared plus the change of y squared. Well, that's all the distance formula is, guys. The distance formula is just a version of the Pythagorean theorem. It's going to help us solve these diagonal pieces. And instead of saying delta x, which we're all extraordinarily talented mathematicians, we know that means change, they said the second x minus the first x. So let's do a couple of these together, and then you guys can start your assignment. So we see our first example here. They gave us 2 points. They want to know how far is it between these 2 points. So we're going to let 1 and 4 be x1 and y1. And we're going to let -2 and 3 be x2 and y2. If these were on a graph, I'm going to guess the one on the right would be the first one we label. But it doesn't matter. And it's beautiful because I'm going to show you all that. So delta, our distance equals the square root of x2 minus x1 plus the square root, or plus the change of y squared. Now the biggest thing to remember is we need to follow our order of operations. So we need to follow our friend PEMDAS. Okay? Parentheses, exponents, multiplication, division, addition, and subtraction. I love these internet challenges where people are trying to figure out how to do this basic stuff that you guys can crush. You probably just laugh at all the little boomers that don't understand or don't remember PEMDAS. So you have something up on them. So remember, we're going to perform the action inside parentheses. We're going to perform the action first. After we perform that action, we're going to get our exponents. And we're going to square the value of our x and y. And that's going to create a positive so we don't end up with negative. And then finally, we're going to add our x and y together. And after all that's done, we can do our square root. So we're going to substitute what we know. Oh, Peter, that's a crooked one. So x2 minus x1. So negative 2 minus positive 1 squared plus y2, 3 minus y1, 4. So we do negative 2 minus 1 is negative 3 squared plus 3 minus 4 becomes negative 1. Now it's important to understand that these squares are going to keep our numbers from being negative. Now some of you have been in Algebra 2, so you understand that imaginary numbers exist. And imaginary numbers were created to help us solve for these kind of problems. But those of you that haven't made it to that level yet, we cannot have a negative underneath the square root. It becomes a no solution. The squares, no matter what happens, if I've got a negative x change, a negative y change, no matter what happens, those squares are always going to make them positive because distance will always be positive. So we get negative 3 squared is 9. Negative 1 squared is 1. And that answer is the square root of 10. All right, let's look at it on the right now. Just because I want to have fun, let's go x2, y2, x1, y1. Because I want to show you guys that it's not going to affect the outcome. So our distance formula, distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. We're going to substitute our values we know. That is an awful one. See if I can't label this guy all out of there. Okay. So we're going 40, or let's say 10 minus 40. Let's write it in the right color so we can differentiate. 10 minus 40 plus 5 minus 45. So we get 10 minus 40 is negative 30. 5 minus 45 is negative 40. These are some big old numbers, and we're going to square them together. 3 squared is 9. Add 2 zeros in there. 4 squared is 16. Add 2 zeros in there. And that gives us the square root of 2500, which is the perfect square for 50. So that's using the distance formula. Now let's do a couple where they give us points. Let's do 14 and 15 together. Okay, so for 14, we need to identify the points first. We've got, what is that, -1, -1. Our second point is 1, 2, 3, 4. +1. So I'm going x1, y1. x2, y2. Plug our values into the distance formula. x2 minus x1 squared. y2 minus y1 squared. Substitute who we know. So we've got 4 minus -1 and 1 minus -1. You guys are smart. You know a double negative makes a plus plus, or whatever you guys say. So we get equals the square root of 5 squared. 4 plus 1 is 5. Plus 2 squared. 5 squared is 25. 2 squared is 4, which is exactly the square root of 29. And if I wanted to, second square root into my calculadora, 5.4 approximately. Okay, last one. I'm just running out of room over there. Let me see if I can't manipulate this rascal, kind of slide him on over Chunder. All right, last one. Find our points first. 1, 2, 3. So we got -3, 0. Down to, what is that? 1, 2, 1, 2, 3, 4. Is that 4? -4, 0. Sorry, guys. Sometimes 0, -4. My apologies. When I'm navigating around in my little box, I get a little distracted. So now I've got my x1 and y1, x1, y1, x2, y2. Again, when we're doing graphs, we generally read left to right. So distance is, let's fill in our little skeleton so we can see it. So we got 0 minus -3 and -4 minus 0. Double negative makes a positive. Oh, Peter. So 0 plus 3 is 3. -4 minus 0 is -4. 3 squared is 9. -4 squared is 16. The square root of 25 is 5. So guys, that is the distance formula on a coordinate plane. Love you guys. Miss you guys. Y'all have a wonderful day.